So I'm continuing on with percent composition problems, and we just said that the previous two problems, whether we do the problem from laboratory data or we use the formula to find percent composition, the values are the same due to the law of definite composition. And so we can then use that law to predict how many grams of oxygen are in a sample. So for example, how many grams of oxygen would a 65-gram sample of aluminum sulfate contain? So to do this problem, we set up a simple proportion. And we know previously that we can use the previous data. If we have 56.11 over 100. This comes from my previous problem where I found that the percent composition was 56.11% out of 100. I know that there are 56.11 grams of oxygen in a 100-gram sample of aluminum sulfate. So I can set up this proportion. And I know that I can put an X for the part, because that's the oxygen, over the whole of 65 grams. And so then I just cross multiply. It's 100x equals 56.11 times 65. So I get 100x equals 3,647 grams. Divide each side by 100, and x equals 36.47 grams. So it's just cross multiplying and dividing. So let's go on, and I'm going to do problem number 8 from page 227 of your textbook. And the question says, DDT, an insecticide banned in the United States, has the formula C14H9Cl5. Find its percent composition. So this is the formula. I'll write that down. And what I have to find is I have to find the molar mass. I have to keep remembering to move up my paper here. I'm sorry I didn't do that in that last one very well. So let's do the carbon part. So there are 14 times the molar mass of carbon from my periodic table, which I'm going to round off to 4 significant digits. So 12.01 grams per mole. So I will multiply that out, and that equals, excuse me a minute. Hopefully I don't run out of lead. That equals 168.14 grams per mole. Okay, I find that for my hydrogen. So I multiply 9 times the molar mass of hydrogen, which is 1.008 grams per mole. and I get 9.072 grams per mole. And then for my oxygen, or not my oxygen, I'm sorry, my chlorine, it's 5 times the molar mass of chlorine from my periodic table, 35.45 grams per mole. When I multiply that, I get 177.25 grams per mole. When I add up all of those numbers, I get 354.5 grams per mole. So remember, this is where I use my part over my whole for my percentage. So for carbon, my part is 168.14 grams of carbon over my whole of 354.5 grams of C14, H9, Cl5. Multiply that by 100, and I get 47.42% carbon. For my hydrogen, my part is 9.072 grams of hydrogen over my whole of 354.5 grams of C14, H9, Cl5 times 100%, and I get 2.559% hydrogen. And my chlorine, my part is 177.25 grams of chlorine. Divide that by 354.5 grams of C14, H9, Cl5. Multiply by 100, and I get 50.01% chlorine. And it's always a good idea to do a check just to see if these add up to 100, and eyeballing it, it does. So that concludes today's sections. And so you should be able to now do your homework using all of this information, which is found on page 240, and it's 15 through 18. So you should be able to do all of those problems using what I just showed you in the last 2 videos. And I will be putting those solutions up soon.